As we go into section 5 of module 6 for the exercise set, we'll take a look at the true-false statements here, 1 through 10. And an interesting thing, there's only one false in all of these expressions. So we may give assignments or we may do them all, I'll tell you. But we'll pause while we work on it. Well, the only one that was false is number 4, where I've written it out in some detail over here. The log, and keep in mind that that's base 10 of 9, and the log base 18 divided by the log of base 2. Well, to prove this, if you put the log of 9 into a calculator, you get this. If you put this into a calculator, you get this. Are they equivalent? And the answer is no. So this is not equivalent, so therefore this statement is false. Now, don't get confused. If you had something like this, log base 10 of 18 halves, if it were set up like so, then this could be simplified to 9. But when you have log of 18 divided by log of 2, then these are not equivalent. All the others are true. And it's probably worthwhile to go through each of these and take a look at them. Let me clear this up a little bit here. The expression log 23 means when there is no base mentioned, it is base 10. That is the common log. Now, the expression ln, which is logrammus naturalis in Latin, but so it's written this way. Instead of being NL, natural log, it's written log natural in Latin. So ln 7 means log, and the symbol E is for the natural logs. That's the symbol E. The number E is approximately 2.7, and we would normally use a wavy equal sign to indicate approximate, and it goes on, and it's an irrational number, never ends, but it's rounded off to that. We've already done 4. The expression log 9 and log 18 minus log 2 would be equivalent there. Now, notice when we did it up here, we divided. Here they're subtracting. So this is what makes it true in statement 5. Here we're dividing. Here we're subtracting. Big difference. Again, the only statement that was false was number 4. The expression log base 2 of 9 and the natural log of 9 divided by the natural log of 2 are equivalent. This is the change of base formula that would be using there. The expression natural log of 81 and 2 natural log of 9 are equivalent. Because remember, this goes up as an exponent. 9 to the second is 81. So these are equivalent. Now, these next few you would have to put into a graphing calculator to see what they look like, and they are true. So for this one, if you remember, when it's in parentheses, it's the opposite sign of what the number is there. So if this is a +2, it's going to start just beyond -2. So in the domain where we're listing the x elements, in a graph it would look like this would be 1, this would be 2. It would start just beyond the 2 and then go up like so. So the x values would be from a -2, and this continues on the x-axis to infinity. And then the range of this function, range would be y values, goes from just above 0 to infinity. And the range of the function given by the natural log of this, again they're saying, goes from the -infinity to positive infinity. Again, you'd have to graph this to see what the graph looks like. I just put it in my graphing calculator, and this is what the graph looks like. Notice this line, as it goes next to the y-axis, gets closer and closer and closer, but never reaches it, and goes down to -infinity. So as we look at our range here, we're going up from -infinity, and eventually this goes all the way up to positive infinity. Okay, some of these were challenging. Now, for these next few, and you will have some like this in your practice, you're going to need your calculator, and they want you to round off to 4 decimal places. So this means you look at the 5th decimal place. If it's 5 or more, you drop it, add 1 to the 4th digit, or the 4th decimal place. If it's less than 5, you just drop it. So putting this in your calculator, you would just hit the natural log button, 5, enter. And the same for all of these. Now for number 15 would be tricky, because it's natural log 2,300. Now you then put divided by 0.08. You don't hit natural log again. Down in number 23, just to show you some other things, it's log of this divided by, now you have to hit log again of this. So you'll have some practice using your calculator to do these, and again your Quizmaze, and then eventually your test. We only have one more section to do in this course.